We are going to start out with circles. So it is one of the important chapter of standard 9th, and few important points are there in this chapter. If you come across with those points, easily you can learn this chapter. So here few basic properties are there which you need to learn. So here let's start out with the thing. So when you are starting out with chapter, I feel like most of you are very clear with what are circles. So here circle is a closed figure where it is having equal distance from the center. So here if we draw an exterior point where it is at equidistance from the center, we call it as circle. And in circles, as I told you, like few basic formulas are there. I hope like everyone know what is radius, diameter, chord and sector, arc. So all these are the basic terms which every student know. So now I am going to make you clear with the formulas of the circle here. So in this formulas we are having the first one, as I told you, like in circle, angle subtended at the center of the circle. So here first formula, here the 5 basic properties you are having. Angle at the center is twice the angle at other part of the circle. So here angle at the center is twice the angle at other part of the circle. So here this is center and this is other part of the circle. If this angle is 90, this will be 45. So this first property we call angle at center is twice the angle at other part of the circle. So this is the first property which they are going to ask in terms of either like MCQ's part, where they will be giving one angle at the center and other they will ask you to find out. So here if angle at the center is 90, angle at other part of the circle will be 45. So in this term, let's solve out with few examples. If angle at the center is given 60, what could be the angle at other part of the circle? Exactly, it's 30. So always it will be half. If it is given 15, angle at other part of the circle, so angle at the center will be double of that. So that will be 30. So this is first property. Now the second property, always when we are starting out with any circle, this part is called chord. So let's learn with few basic terms of circle. Here in the circle, this is called chord. The part which is enclosed here. So here the part is got divided into two parts. This half part is called arc, that is this is smaller arc. So we call it as minor. And this upper one is called major arc. Circle got enclosed with two circular halves. If a chord is drawn, chord is dividing the circle into minor arc and major arc. Then here the chord parts are there, a smaller chord part is there and the major one. So this is called minor chord, this is called major chord. Then students often get confused with what is secant and what is tangent. the line which passes through the circle, if you draw a line, if it is passing out through the circle, we call this to be secant. And that is, it has to cross out. Whereas in the chord condition, line will be in the circle only. It will not cross. So this is called chord. This one is called secant. And if a line joins the circle at only single point, we call it as tangent. So here we got with three different terms. One I said chord, the second one as tangent, and the third one as secant. So this line is called secant, which is crossing the circle fully, and the line which joins the circle at single point is tangent, and the line which joins the circle at 2 points is called chord. So there are different kind of chords. So here different, like we can draw many chords in the circle. For example, this is one chord, this is one chord. So among all the chords, the line which passes through the center is the longest chord. This again can be 1 mark question. What is the longest chord of the circle? Longest chord of the circle is diameter. Diameter is the longest chord of circle. So among all MCQ questions, as I told, angle at the center is twice the angle at other part of the circle. That is one of the important question. And the next one, circle chord is the diameter is the longest chord of circle. That is second important question. So here I am feeling little uncomfortable to write in that way. So let's adjust out with my notebook here. So give me a few minutes time here. So let's now move out with the important questions as I told you. So first property as I told, here the circle angle at the center is twice the angle at other part of the circle. So this is the first property. If we draw an angle at the center, this will be twice the other part of circle. So this is first property. Angle at center is twice the angle at other part of circle. Next, if suppose we draw a circle, suppose in a circle many angles are drawn on the same chord. Like here AB is the chord, and we drew many angles like this. This is one angle, this is one angle, this is one more angle. In circle, these all are called angle of same segment, and angle of same segments are always equal. So this we call angle of same segment. And if suppose this first angle is 30, the second will also be 30, third will also be 30. So how we are going to identify it? For that, you need to see that their starting and ending points are equal. So here A and B, that is the part of the chord, every angle got formed on that only. So all the angles will be equal. This we call angle of the same segment. This second property, angle of same segment. Now next, third property, if in a circle there is a quadrilateral. Quadrilateral is a closed figure made of 4 line segments. If there is a quadrilateral in the circle, we call it as cyclic quadrilateral. Cyclic means inside the circle, and this is the symbol of quadrilateral. Instead of writing complete spelling, you can use quadrilateral symbol. In cyclic quadrilateral, opposite angles are supplementary. So these two are opposite angles, A and C. This will be supplementary. Supplementary is nothing but their sum is 180, and the same way angle D and B, they are also supplementary. Their sum is also 180. This is in cyclic quadrilateral, opposite angles are supplementary. So this is next property. Then fourth property, angle of semicircle. If we draw an angle of semicircle, it's always 90. So how we are going to draw angle of semicircle? So it must be diameter. Any angles on the semicircle, they are always 90. This is the next important property. So these are the most important properties of circle. Once again, I am repeating those who joined now. The first one, angle at the center is twice the angle at other part of the circle. The angle must form from the same point. That is that initial and final points must be same. So here angle formed on the center and other part of the circle. Always here the center angle will be double to angle at the other part. If this is 30, this will be 15. The second one, angle of the same segment. If we have the same common chord, you can check out that the angles starting arm and its ending arm, they are equal. When the arms are equal, these are called angle of same segment, and angle of same segments are always equal. Now the next part, like the third part, third property, in a cyclic quadrilateral, opposite angles are supplementary. In cyclic quadrilateral, opposite angles are supplementary. What is called cyclic quadrilateral? A quadrilateral which is formed on a circle. Quadrilateral which is inside the circle is called cyclic quadrilateral. In cyclic quadrilateral, always opposite angles are supplementary. So here angle B and C will be supplementary. Now coming to the next part, angle of semicircle. If a diameter is taken, angle formed on diameter is called angle of semicircle, and angle of semicircle is always equal. So here these are the important properties. So let's move out with now question. Among all the exercises, 9.2 and 9.5, that the last exercise are very important, where out of 9.2, question number 5 and 6, they are the definite questions. So these questions are very often asked. So let's start out with the solution part now. In the first question, it is given two circles having the radii. There are two circles, their radius is 5 and two circles are there. Their radii is 5 and 3. They intersect at 2 points and the distance between their centers is 4, and so here they intersect at 2 points. Center of the circle's distance is given 4. So this distance is 4. And the radius of the circle is given 5. So this is 5. This radius is given 3. And this complete distance is given 4. We need to find the length of common chord. So this chord we need to find out. So how we are going to find this chord? So for that, first let's consider this part to be x, and the remaining part will be 4 minus x, as the complete distance is given. If I'll consider this part to be x, this part will be 4 minus x. So here, if it is 4 minus x, we can apply Pythagoras theorem here. Label it. Let the chord be AB. Centers be O and O dash. This part is x. This part is 4 minus x. Now how we are going to solve it? So let's move with that part. Here, if I'll consider triangle OA, if this part is M, OAM, angle M is 90. So we can apply Pythagoras theorem here. In Pythagoras theorem, OM square plus AM square is equal to OA square. Now what is OM value? OM is given x, which we considered. AM we need to calculate, and AO is given 5. So let it be 5 square. AM square is 25 minus x square. So let this be first equation. Now let's start out with the second part. In second part, am square plus mo dash square is equal to 4 minus x square. So here am square and om dash square is 4 minus x square. Am we got 25 minus x square. Om square, it's 4 minus x. Here you can see it is 4 minus x. So this we can replace with 4 minus x square is equal to, out of this, here we'll be getting OA square, OA dash square. So OA dash is 3. Now expand it, 25 minus x square plus 16 minus 8x. I am applying the formula of a minus b whole square. So 4 minus x is there. So it's a square is 16, 2ab, 2 multiplied by 4 is 8, and then x plus x square is equal to 9. Now x square term will get cancelled. So cancel out both the x square terms. After they are being cancelled, 25 plus 16, it's a, see here we need to calculate all the values. I am shifting everything towards right side. Minus 8x is 9 minus 25 minus 16. Now 9 minus 25 minus 16. Find out the value. So here 25 plus 16, it's 41. 41 minus 9, it's 32. Minus 8x is minus 32. So minus got cancelled. Thus x is 4. You got the value of x. But you need to find out what is am square. So how to get am square? Am square, it was 25 minus x square. X we got 4. So replace it with 4. 25 minus 4 square. So it is 25 minus 16. 25 minus 16, it's 9. Thus am is 9. Am square is 9. So am will be root over 9. Root over 9 is 3. We got the value of am. But we need to find out what is chord AB. Once again, if you recall the circle. So here in the circle, am was, so here the two circles were intersecting each other. So here I took it as am. So this part we got 3. We need to find out complete chord. So complete chord will be double of that. Therefore, AB is 2 multiplied by 3. So it's 6. This is the value of AB. So this we got. Now the second question, it is also most important question of this exercise. So I want you to concentrate for this question. So here in this question, it is given, if two equal chords of a circle intersect within the circle. Here 2 equal chords are there. In the circle, chords are equal. So already I explained what is chord. So in the circle, what we call to chord? 2 equal chords intersect each other within the circle. It is given. So here AB and CD, let they be equal chords. And here they are intersecting. So let me consider this point to be O. We need to prove that the segment of the chord are equal to corresponding segment of other chord. So here in this, if I consider this to be P, what we need to prove? Here it is given AB is equal to CD. Equal chords intersect at point P. To prove, we need to prove AP is equal to corresponding part PD or DP. And the same way CP is equal to BP. This we need to prove. So this is to prove part. Now here, how we can start out with the solution. Already in chapter number 7, you completed with the similarities of triangle. So that same part we are going to use here. First, in construction, we'll take the center of the circle and from there we'll drop out two perpendiculars. So here, from circle, if we drop two perpendiculars, let they fall at the places M and N. O be the center of the circle. So this is the construction part. In construction, draw perpendicular OM and ON on AB and CD respectively. Now join OP. So this is our construction part. Join OP. You can see there is formation of two triangles. So in proof part, we come across with that. Here in the proof, in triangle OMP, in triangle OMP and triangle ONP, what you can find in these triangles? The first point, OM is equal to ON. This is one of the important property of the circle. Equal chords are equidistant from the center. So this we call equal chords are equidistant. That is, the distance is equal. Then the second one, angle M is equal to N. As you know, they are perpendicular. So their measurement is equal, each 90. Third point, here OP is common. So this part already you learned in chapter number 7, where you did with similarities of triangle. The same concept we are using over here. So here OP is equal to OP. This we call common. Now both the triangles are similar. Therefore, triangle OMP is similar to triangle ONP. So how it got similar? By two sides and one angle is equal. Moreover, OP is hypotenuse. This is 90. So we call the property as RHS. So as the triangles are equal, we can make angles to be equal. So as these triangles got congruent, so these two angles will be equal. So if I'll consider this to be angle 1 and angle 2, then, or we can write like, therefore angle OPM is equal to angle OPN. Now these two triangles got congruent by CPCT. If you recall back chapter number 7, you can remember all these properties. So by CPCT, these two angles got equal. Now once if the angles are equal, we can make any any other parts to be equal. So here the angles got congruent by CPCT. When the angles are congruent, this is the next third question where you need to make angles equal. Here in this fourth question, you need to make the corresponding parts equal. So by CPCT, we will make MO, that is this part is P, PM is congruent to PN. So by CPCT, PM is equal to PN. So this is also by CPCT. Now let's have the continuation of this part. When we drop a chord from the, when we drop a perpendicular on the circle, it divides the circle into equal, it divides the chord into equal halves. So this is like if you drop a perpendicular. So in this figure, how we were having two chords were there and we dropped a perpendicular on the chord. Center was O, M, N and this was P. Chords were AB and CD. So in this figure, we dropped perpendicular and we made these triangles to be congruent. When the triangles were congruent, by CPCT, I made this part and this part to be equal. So here, MP is equal to NP. Now, as the chord is on equal circles, it will divide the chord in equal parts. That is, Though in the figure it is not looking like that, I dropped this chord from the center. So in the circle there is a property, whenever we drop a line from the center, it will divide the chord in equal half. So that property we are going to use here. So here OM perpendicular on AB and ON perpendicular on CD. Therefore, here AM will be equal to BM. In the same way, CN will be equal to DN. That is, perpendicular from the center will divide the chord in equal halves. This is another property. Perpendicular from center divides chord in equal halves. So the halves are equal. So here we got one equation, and in previous case one more equation was there. If we will add these two. Now adding equation 1 and 2. If we will add it, MP plus AM will be equal to NP plus BM. What is MP plus AM? MP plus AM, it's completely AP. So in place of this we can write AP, and the same way by adding these two we can write PD. Here this only we need to prove for the first case. Okay, now when chords are equal, before it was given AB is equal to CD. Out of this, if we subtract this part, so let this be third equation. Now subtracting, if I'll take this to be 4, subtracting 3 from 4. So if I subtract it, AB minus AP will be equal to CD minus DP. Now when they got subtracted, here if I'll subtract it, when they got subtracted, AB minus AP. So here out of AB, if I subtract AP, we left out with PB. So here we can write PB, and the same way here we can write CP. So here it will become like PB is equal to CP. This is the final proof which we need to make. So here the 2 points, these two only we need to prove. So this we got finally completed with. Once again I am repeating only with the figure here. So in the figure it was given like two chords are equal, and from the center two perpendiculars were dropped. The chords are intersecting each other at P. This I consider it was not given. Even the chords naming we can make like AB and CD as per your choice, and then take the center as O and two perpendiculars as M and N. Join this, these all will come in construction. First part, you need to make these two triangles congruent as per the 7th chapter concept. Once you make this triangle to be congruent, this part will become equal by CPCT. And when we drop a chord will divide the circle in equal halves. So this part will be equal to this part, and the same way this part will be equal to this part. And then in equal part, when we join this, it will make the AP to be equal. So this is what we completed. So most probably I feel like everyone understood. So in this we are having total 2 exercises. The one was as I told, like 9.2 and 9.3. Those exercises are very important. And if you learn question number 2, third is fully like same, where you need to make only these two angles equal. Already you proved triangle to be congruent. So after making the triangle to be congruent by CPCT, you can make angle equal. So tomorrow we'll continue with the rest of the part, where you can learn it much more nicely. Okay, so those who attended, thank you for attending. For having much more clear knowledge, attend it in the next session also, so where you'll be getting the full complete explanation. So I'll try to complete out this 9.2 tomorrow, so where we'll be completing out with each and every question clearly. Thank you for watching and attending. So let's wind up class now.